At precisely 5:12 a.m. on November 23, 2025, a faint signal slipped into a raw frame from the infrared Sentinel array in Chile. It was a routine data capture, no alarms, no urgency. A long-scheduled calibration frame filed under a standard update to orbital object tracking logs. But as the data flowed into the secondary analysis queue, something stood out. Not in the brightness levels or the flare background, but in the shape. An unfamiliar object, large, cold, and geometrically stable, had entered the field of view. It bore no known signature. Its name in the system was temporary, UN271. That code, for most observers, would mean nothing. But for a select few planetary physicists monitoring the orbital position of 3I-ATLAS, it raised immediate questions. The thermal emission pattern was strangely familiar, too familiar. UN271 mirrored characteristics that had, until now, only been seen in one other object. The core temperature curve, the infrared absorption valleys, and even the motion blur profile all matched previous readings from 3I-ATLAS with disturbing accuracy. A second object, a possible twin. Yet no announcement followed, no early bulletin from the International Astronomical Union, no confirmation from NASA. The object simply appeared, quietly embedded in the observational matrix, like a shadow mimicking a silhouette. It wasn't until independent analysts began comparing tracking logs that the eerie symmetry became clear. The new object had no inbound trajectory, no approach curve from outside the solar system, no historical detection record. In short, it had not arrived from anywhere. It had emerged, and its emergence was perfectly timed with a window of increased electromagnetic activity from 3I-ATLAS itself. For the amateur astronomy community, this discovery reignited tensions that had been simmering for weeks. Many had grown sceptical of the scientific establishment's silence around 3I-ATLAS, especially after it passed perihelion without the outgassing behaviour expected from any comet-like body. But now, with a second object mirroring its profile, those suspicions deepened. The narrative that this was just another interstellar visitor began to unravel. UN271's lack of tail, coma, or sublimation jets immediately classified it as an anomaly. Standard comet models couldn't explain an object of that mass, passing that close to the Sun, without releasing detectable material. And yet here it was, stable, unreactive, and silent. Even more unsettling was its orbital position. UN271 was not trailing 3I-ATLAS, nor was it preceding it on a hyperbolic path. It was beside it, mirroring its arc, maintaining a calculated distance like a formation flyer. The implications of this were enormous. In celestial mechanics, two bodies sharing a near-identical path without gravitational interaction are statistically improbable. A twin trajectory suggests one of two things: either a deeply rare binary object system that somehow entered the solar system unnoticed, or a controlled formation, and if it's controlled, the entire premise of passive interstellar drift collapses. Back at the Sentinel array, scientists began rerunning simulations. They entered the new mass reading, recalibrated for the reflected thermal signature, and mapped the projected course. What emerged was chilling. Within 48 hours, both 3I-ATLAS and UN271 would converge to within 0.06 astronomical units of each other, while crossing Earth's orbital plane. Not in collision, in sync. Still, no public update came. Inside encrypted channels used by European and Chinese observatories, murmurs of reflected origin and vector-locked pair began surfacing. UN271 wasn't just an object, it was a signal, a duplication, a behavioural mirror, and its silence, its lack of any public context or institutional classification, was louder than any warning siren. As the morning passed, the object slipped further into alignment with 3I-ATLAS. What had begun as a routine image capture was quickly turning into one of the most unsettling discoveries in interstellar astronomy. Not because of what was seen, but because of what no one was willing to say. The object had no announcement, and that silence speaks volumes. The signal came quietly. Buried in the lower half of the spectrographic output from the James Webb Space Telescope's NIR SPEC instrument, the data didn't initially trigger any alerts, just another exposure in a long sequence of routine scans, captured over the course of the early hours of November 23, 2025. But as teams at the European Space Agency began reviewing the data set for known chemical signatures, a pattern began to emerge, one that mirrored previous recordings from 3I-ATLAS, and one that defied the known laws of cometary chemistry. It started with nickel. Again, spectral echoes. Precise emission bands repeating in intervals across different objects are rare. Most celestial bodies present a unique chemical fingerprint, shaped by billions of years of cosmic history, local star formation, and random processes. But when analysts compared the chemical absorption lines of this new object, UN271, to those of 3I-ATLAS, the overlap was nearly perfect. A sharp nickel line with no corresponding iron trace. This wasn't just statistically unlikely, it was chemically impossible under natural formation models. The resonance across multiple wavelengths was even more puzzling. UN271 didn't just match 3I-ATLAS in nickel emissions, it pulsed in the same way. The 35-micron thermal peak, previously identified as the central pulse of 3I-ATLAS, was now appearing in UN271. The interval, precisely 11.2 hours. The amplitude change, 2.4%, within 0.06 of the original anomaly. In isolation, this might have been dismissed as coincidence or instrument artifact, but coming from a separate mass, recorded through different sensors, it became undeniable. It was an echo, a duplication, but not in time, in composition, and behaviour. Cross-referencing data from Mars Express and the Tianwen-1 spectrometers confirmed what Webb had seen. Each instrument, operating independently, captured the same harmonic curve in UN271's emission profile, a thermal fingerprint that matched its supposed twin in both tempo and structure. This was no ordinary comet. It wasn't even clear if it was a comet at all. Further complicating the picture was the lack of expected noise. Most spectral recordings from active comets are chaotic. Spikes of carbon monoxide, water vapour, formaldehyde. Jets create turbulence in the surrounding coma, introducing noise into the signature. But UN271's output was remarkably clean. There were no stray bands, no overlapping molecules, just the pure signal of vaporized nickel and narrowband mid-infrared pulses. It was almost deliberate. Scientists at ESA began to ask difficult questions. Was this truly a separate object? Or was it a fragment, detached from 3I-ATLAS in an earlier maneuver? If so, how had it retained an identical spectral structure? Fragments usually evolve rapidly, breaking down, exposing new material. Instead, UN271 seemed not just stable, but patterned. The possibility of signal synchronization was also raised. If both bodies were emitting light at identical intervals, could it indicate communication? The pulses weren't modulated in the traditional sense. There was no binary, no data encoding, but the phase lock was too precise to ignore. It hinted at coordination, if not control. And then came the strangest echo of all. In the deep infrared range, beyond even the reach of NORSPEC's calibrated response, a low-frequency undulation was detected. At first, it was dismissed as cooling noise, but after digital enhancement, the wave showed structure, a modulation consistent with rotational harmonics, spaced in Fibonacci ratios, 5, 8, 13, the same pattern that once appeared faintly in the coma of 3I-ATLAS, now doubled, now louder. UN271 wasn't just similar, it was synchronized, and in astronomy, synchronized behavior across two unconnected bodies doesn't happen by chance. It demands an explanation, a system, a model beyond anything known in natural formation theory. The spectral echoes continue, but they are no longer being heard from just one object. Now, there are two. For centuries, one feature has defined comets beyond all others, their activity. As these icy visitors approach the sun, they sublimate, releasing gas and dust into space. This process creates the familiar coma, a glowing cloud that surrounds the comet's nucleus, and often two distinct tails, one of ionized particles, the other of dust, both pushed away by solar wind and radiation pressure. The coma is not optional, it is fundamental to comet identity. But UN271 defied that definition completely. On the morning of November 23, 2025, updated imaging from the Sentinel Array and the Goldstone Solar Tracking Network confirmed what amateur observers had already begun to whisper. The object exhibited no visible signs of outgassing. Not even a trace. No coma, no jetting, no diffuse halo of vapour, just a cold, dark object moving quietly through space. This same silence had already characterised 3I-ATLAS weeks earlier. Despite its proximity to the Sun and the intensity of solar radiation it received at perihelion, the object had failed to develop a proper coma. That anomaly had been brushed aside by some researchers, attributed to possible crust hardening, volatile depletion, or other theoretical edge cases. But now, with UN271 presenting identical behaviour, those excuses no longer held weight. Two objects, no coma, no tail, and more importantly, no explanation. The standard model for comet activity hinges on the presence of volatiles, primarily water ice, carbon dioxide and carbon monoxide, that convert directly from solid to gas as heat increases. The escaping gas drags dust particles with it, forming the coma. It's a universal rule, one that had never been broken until now. Thermal scans of UN271 showed a temperature profile consistent with exposure to solar flux, meaning it was absorbing heat. But there was no corresponding activity. The surface remained inert. Spectral readings showed no signature of gas release, no water, no carbon chains, only the recurring trace of vaporized nickel, something comets aren't supposed to carry in free gas phase form to begin with. Some propose that the object was covered in a crust, a non-volatile shell preventing sublimation. But if that were the case, it should have cracked under the thermal strain. Others suggested it was simply too early for outgassing to begin. But UN271 was already deep inside the coma formation threshold. It had passed the so-called activity line nearly 24 hours earlier. By now, any ordinary comet would be fully active, glowing, shedding material. Instead, what scientists observed was stillness. The absence of a coma isn't just a visual anomaly, it's a physical contradiction. Without outgassing, there's no known mechanism to explain the slight course adjustments both UN271 and 3I-ATLAS exhibited over the past few days. In normal comets, asymmetric jets can push against the nucleus, altering its trajectory slightly. That process is chaotic, unpredictable, and visible, but these objects were drifting smoothly. No jets, no expulsion, and yet their paths continued to adapt. The coma also serves another role, insulation. As gas escapes, it cools the surface and regulates energy distribution. An object without a coma should overheat, fracture, disintegrate. Yet both 3I-ATLAS and UN271 remained intact, even as solar radiation peaked. This led to a far more uncomfortable hypothesis. What if these objects don't need a coma because they're not made of ice? What if they're built, structured in a way that resists sublimation, that absorbs heat without vaporizing? What if what we're seeing isn't a failure to outgas, but a feature, a design? With no jets, no halo and no trailing tail, UN271 moved like a ship, not a comet. It did not shed, it did not scatter, it simply glided forward, silent, dark, unchanging. And that silence now echoes twice. In a sky where comets are supposed to scream, these two anomalies whisper. Not because they're failing, but because they were never meant to behave like comets at all. The discovery of UN271 should have followed a predictable sequence. A detection by a deep sky survey telescope, cataloguing of its inbound trajectory, and classification as an interstellar object based on velocity and orbital eccentricity. But that sequence never happened. When analysts began tracing back the orbital path of UN271 on November 23, 2025, they found nothing. There was no record of approach, no observation arc from any sky survey, no early brightness curve logged in the Pan-STARRS archive, no blip in Gaia's photometric data. Even the Near-Earth Object Wide-Field Infrared Survey Explorer, known for flagging small inbound comets, had logged 0 relevant detections. UN271 had simply appeared. This was not just unusual, it was unprecedented. Every known interstellar object, from Oumuamua in 2017 to 2I Borisov in 2019, had been detected on approach. Their speeds, origins, and inbound paths were all mathematically consistent with an extrasolar origin. But UN271 had no inbound path. When orbital models were run in reverse using its current position and velocity, they terminated abruptly. The equations diverged. UN271's vector didn't trace back to interstellar space. It pointed inward, toward the solar system. But how could an interstellar object enter from inside? Some theorists proposed a hyperbolic slingshot past Jupiter or Saturn, an obscure high-energy flyby that could have altered its trajectory and masked its origin. But no such encounter was found in planetary telemetry. The gas giants were nowhere near the calculated path. Others suggested that UN271 might have been hiding in the solar blind spot, near the Sun, making detection difficult until it emerged. But this would have required UN271 to somehow maintain velocity and direction, while avoiding detection by space-based solar observatories like SOHO and Stereo. That too was impossible. The object's own motion was calm, linear, not erratic, not spinning, not deflecting. It presented the behaviour of something inserted, not ejected, something placed, deliberately or not, into a stable arc just beyond our instrument's reach, waiting for its moment to cross into visibility. Some described this as a registration problem. In astronomy, when an object is catalogued, it receives a formal designation and is registered in systems like the Minor Planet Center or JPL's Horizons database. UN271 had no registration until the day it appeared. No provisional ID, no precursor fragments. Its first detection was also its first presence. And then came the comparative drift analysis. When astrophysicists plotted the orbital drift between UN271 and 3I-ATLAS, they noticed a stunning alignment. The two objects shared a near-identical angular velocity across several observation windows. Their orbital planes weren't just similar, they were matched to within fractions of a degree. This was no chance crossing of interstellar paths. The odds of two separate objects independently achieving such tight alignment, without gravitational tether or historical encounter, were virtually nil. This raised a more difficult question. If UN271 had no trackable origin, and its motion mirrored 3I-ATLAS, was it possible the two objects had entered the system together? If so, that would mean the entire observation timeline for 3I-ATLAS had been incomplete, that we'd been watching only one part of a larger system, without knowing the other part was hidden. This twin insertion hypothesis, as it began to be called in internal ESA briefings, rested on the idea that both 3I-ATLAS and UN271 had been moving in synchrony before detection, one visible, one cloaked by glare, trajectory or proximity to the solar blind zone, and if true, it also implied that the appearance of UN271 was not random, it was timed. A hidden twin revealed only after its counterpart had passed perihelion and triggered global attention. UN271 was unregistered, undetected, unexplained, and yet utterly aligned. It did not come from the outer void. It came from silence. And now, silence is the loudest signal in the sky. Infrared instruments are the sentinels of space. They do not rely on visible light or reflective surfaces. They look for heat, raw, measurable, and revealing. Every object in the solar system emits infrared radiation proportional to its temperature and surface characteristics. Comets, in particular, show distinctive thermal profiles when approaching the Sun. Active ones glow unevenly. Their jets create localized hotspots. Their comas scatter heat. Even dormant comets display thermal gradients as they rotate and absorb solar energy. But on November 23, 2025, the thermal readings from UN271 triggered something unexpected. Nothing. ESA's infrared survey system, along with support from JAXA's Hayabusa 3 spectral relay, detected no meaningful temperature differential across the body of the object. It was uniformly cold, not freezing in the classic sense, but flat, even, silent. And that silence wasn't just strange, it was statistically wrong. UN271 had just passed its closest solar approach 2 days prior. By all models, it should have shown signs of heating. Some edge of its surface should have registered a thermal spike, even if outgassing was absent. But the object's profile remained a smooth plateau. No hotspots, no shadows, no indication of heat absorption or re-radiation. It was as if it wasn't interacting with solar energy at all. This was not the first time such a signature had emerged. When 3I-ATLAS reached perihelion, its thermal map had shown similar suppression. Scientists had proposed exotic insulating surfaces or crustal shielding as a possible explanation. But these were guesses, ideas stretched to fit data that refused to conform. With UN271 now displaying the same eerie quiet in infrared, the phenomenon could no longer be dismissed as a one-off. It was a pattern, a silence that repeated, a silence that scaled. The lack of thermal contrast made modelling the object's shape and spin rate nearly impossible. Normally, thermal data can help scientists infer rotation speeds based on day-night cycling. As one side of an object turns into sunlight, it heats. As it rotates away, it cools. That rhythm creates a thermal oscillation, a kind of heat pulse. But UN271 gave no such rhythm. If it was spinning, the rotation produced no detectable change. If it was absorbing light, that energy left no trace. There were deeper implications. The infrared flatline hinted that UN271 might not be reflecting or radiating energy in any conventional way, that its surface might be absorbing photons and converting them into something else, mechanical, magnetic, or something currently beyond terrestrial understanding. The object was not cold because it couldn't be warmed. It was cold because it refused to reveal the warmth it received. This effect, thermal suppression without material shedding, is not known in natural comet behaviour. It implies a fundamentally different interaction with radiation, possibly even a surface engineered to disperse energy across dimensions that standard instruments can't detect. NASA's analysis teams quietly published a redacted advisory to thermal calibration teams working with JWST, noting non-standard IR baselining observed in comet-class objects 3I-ATLAS and UN271. But internally, the term thermal null had begun to circulate, a state where an object appears to be participating in solar physics but yields no thermodynamic evidence. Worse, when analysts attempted to compare the object's surface albedo to its thermal emission, they found a mismatch. Normally dark objects absorb more heat, while bright ones reflect more. But UN271 absorbed sunlight like coal and emitted heat like glass. It made no physical sense. It defied Stefan Boltzmann radiation law, and yet it was real. This wasn't just quiet, it was calculated, purposeful. A thermal silence that pointed not to natural erosion or exotic insulation, but to intent, as if the object had been built, shaped, and sent forward not only to pass through the solar system, but to avoid being seen while it did. When orbital analysts at ESA's Dynamics Lab ran comparative models between 3I-ATLAS and UN271, they expected some variance, different insertion points, different energy profiles, different angular trajectories. But what emerged from the simulations was something they were unprepared for, a mirrored arc. UN271's orbital path was not only similar to 3I-ATLAS, it was geometrically reflective. Over a 72-hour simulation window following perihelion, both objects traced near-identical shapes across the inner solar system, but on opposite sides of the ecliptic plane. When mapped in 3 dimensions, their trajectories formed a kind of interstellar bow, 2 sweeping curves pointed inward, facing each other across a near-perfect central axis. This was not orbital coincidence. This was structure. That structure had a name inside mission control, the orbital mirror. In celestial mechanics, mirrored orbits are rare but not unheard of. Some resonance pairs in Saturn's rings show harmonics that mimic each other on opposite sides of the planet's axis, but those are natural byproducts of long-term gravitational interactions. What made 3I-ATLAS and UN271 different was the precision of their symmetry and the timing of their visibility. They were not always visible together. They became visible at nearly the same moment. On November 23, 2025, when UN271's reflected path brought it to the same longitudinal point 3I-ATLAS had passed 5 days earlier, it appeared in amateur telescope captures across the southern hemisphere, right where it mathematically should have been. But it had not been there before. That abrupt appearance made one thing clear. We had been looking in the right place all along. We just weren't seeing it. Some theorists suggested this reflection was gravitational, a shared origin or launch geometry that caused the 2 objects to spiral in opposite arcs. Others argued for magnetic guidance, invoking interactions with solar plasma fields, or even a passive resonance with Earth's heliospheric current sheet. But none of these ideas could account for the sharpness of the mirror, how tightly the curves matched, how synced the timing was. NASA's Internal Orbital Alignment Report logged the delta-v difference between the two arcs as less than 0.01 kilometers per second, a figure so small it approached controlled motion. Not just interstellar drift, not just gravitational assistance, but guided flight. There were more details hidden in the curves. UN271 and 3I-ATLAS did not simply mirror each other in path, they mirrored in velocity profile, perihelion distance, and even radiation exposure angle. Their light curves, measured in microlensing fluctuations, showed matching troughs and rises spaced precisely 5 days apart. It was as if one was watching the other, or worse, tracking it. This gave rise to a new line of thinking. What if these objects weren't siblings? What if one was the observer and one the target? The orbital mirror implied coordination, not just similar paths, but reactive design. When one turned, the other echoed. When one crossed a trajectory node, the other arrived 5 days later, always behind, always offset, always synchronized. And that raised a final question no one wanted to write in their reports. If this is a mirror, what's on the other side? In physics, mirrors reflect information. They allow one observer to deduce the presence of another through reflection. But in orbital dynamics, a mirror implies intention, planning, geometry that doesn't arise by chance. UN271 didn't just show up beside 3I-ATLAS, it showed up because of it. And now the sky shows us both. A silent pair, a mirrored dance, and something watching in the gaps between them. There are numbers in nature that do not simply occur, they replicate. The Fibonacci sequence is one of them. From the spiral of nautilus shells to the arrangement of sunflower seeds, it appears again and again where structure meets growth, where chaos finds symmetry. But on November 23, 2025, it appeared somewhere it had never belonged before, the telemetry shadows of an interstellar object. When ESA's deep field radar systems scanned UN271's reflective signal across 3 passes, they noticed something subtle, not in the shape or density of the object itself, but in its shadow. Radar shadows occur when a signal is blocked or delayed by protrusions or irregular surfaces on an object. The shape and timing of those shadows can reveal surface features and motion, but UN271's shadow wasn't just irregular, it was recursive. The peaks and troughs of radar attenuation followed a pattern, one that repeated with increasing intervals, one that matched the ratio 1, 1, 2, 3, 5, 8, 13. The Fibonacci sequence. At first, mission analysts thought it was a software artifact, compression error, packet drift. But after reprocessing the raw phase return data, the same signature emerged again. A recursive dip in signal strength, followed by a longer echo, then a longer one still. It was as if the object wasn't simply reflecting radar, it was modulating its returns. The implications were staggering. The pattern suggested that UN271 had structured surfaces, possibly ridges, indentations or nested contours, arranged in Fibonacci proportions. These aren't naturally expected in comets. Even Oumuamua, with its pancake flat profile, showed no signs of recursive geometry. But UN271 did. More advanced scans followed. ESA's orbital interferometry system, 3 satellites forming a synthetic aperture tens of kilometers wide, ran cross-phase imaging. The result? A spiral. A logarithmic spiral, consistent with golden ratio formation, the same pattern that emerges in growth algorithms, fluid dynamics, and antenna design. A pattern that could serve both form and function. Some at JPL floated a theory. The Fibonacci geometry wasn't decorative, it was behavioral. A passive system to manage solar radiation, perhaps a thermal buffer, perhaps a signal amplifier, or perhaps both. But it wasn't just the shape, it was the timing. The recursive pattern in the radar shadows occurred every 233 seconds, not 232, not 234, exactly 233. Another Fibonacci number. These weren't coincidences, they were confirmations, and they raised a deeper possibility. What if? The object wasn't just surviving space. What if it was communicating? Fibonacci patterns are universal, recognizable, self-similar across scales, used in compression algorithms, logic gates, digital encoding. If an intelligence wanted to prove its non-random origin using only shape and silence, Fibonacci would be the language. The shadow said more than the light. And perhaps most disturbingly, it matched something else. When researchers cross-referenced the 3I-ATLAS light curve from 2 weeks earlier, they found a faint modulation in visible light. Not enough to trigger alarms, but enough to sketch the start of the same recursive rhythm. 1, 1, 2, 3. The pattern now appeared in both bodies. The Fibonacci spiral wasn't just carved into the skin of UN271. It was embedded in their motion, in their silence, in their delay. A message that doesn't need words, just structure, and just enough time for anyone to notice. The sky's full of noise, radio bursts, thermal echoes, cosmic rays, and solar wind distortions. Every day, instruments around Earth filter out billions of data points just to isolate the ones that matter. But on the morning of November 23, 2025, one signal didn't need to be found. It found them. It came from UN271. The object was already under intense observation. After its appearance alongside 3I-ATLAS, every major observatory, ground and space-based, pivoted its resources to focus on it. Most were watching in the optical and infrared spectrum. But one array, the Allen Telescope Array in Northern California, was sweeping the skies with a broadband passive scan when it picked up a pattern. It wasn't a transmission in the usual sense. No encoded message, no burst packet, no frequency hopping. It was a steady rhythm, a low pulsing wave buried deep in the background noise. When signal engineers plotted its amplitude against time, they saw a waveform emerge, symmetrical, tapering, recursive, and then they saw the harmonics. The signal emitted from UN271 wasn't a single tone, it was a harmonic ladder. Each higher frequency component was an exact multiple of the base frequency, spaced by consistent intervals. This kind of frequency architecture doesn't appear naturally in drifting comets or tumbling rocks. It was structured, purposeful. Initially, the team considered equipment interference, but when the signal was independently confirmed by radio dishes in Australia and South Korea, doubts vanished. The signal was real, and it was coming from one place, the space directly surrounding UN271. What made it more compelling was its interaction with time. The pulses were not random. They were phase-locked to Earth's own rotation. Every time the same longitude passed under the object's orbital arc, the pulse's amplitude increased. It was as if the object knew when it was being watched, and responded. This phase-locking behaviour led to a new hypothesis. The UN271 signal wasn't broadcasting, outward. It was reflecting, reacting, using Earth's motion as a baseline for synchronization, a signal that doesn't call attention to itself, but can't help but reveal its design under scrutiny. This became known internally as the UN271 signature. Spectral analysis showed a central band in the microwave range, between 2.83 and 2.87 GHz, flanked by weaker harmonics spaced at golden ratio intervals. Yes, golden ratio intervals. The same constant that defines the Fibonacci spiral. The same constant that shaped the object's geometry. The overlap was no longer theoretical. It was measurable. The spiral was in the shape. The spiral was in the shadow. And now, the spiral was in the signal. Some compared it to a beacon, an intelligent lighthouse casting information not through light, but through pattern. Others saw it as environmental feedback, an unintended artifact of unknown machinery, like the sound of a ship's engine echoing through the hull. But both agreed it was artificial. No natural object hums in the golden ratio. More concerning was the modulation rate. At first glance, the waveform seemed passive, but layered within it were micro-oscillations, flickers no longer than 1/10 of a millisecond. That flicker pattern, when converted into binary format, yielded a structure. Repeating loops of 13, and 13 was the last Fibonacci number observed in the radar shadow pattern. One signal, one ratio, 3 different systems, geometry, reflection, and now radio, all saying the same thing. This was not noise, this was a signature, and if a signature exists, so must a signer. It was just one frame, one single capture taken by an amateur observatory in Chile during a 2-minute window on the morning of November 23, 2025. The equipment was modest. No cryogenic cooling, no adaptive optics. Just a cooled CCD sensor, a wideband filter, and a clear southern sky. and yet it saw something no one else had. The image showed a familiar silhouette, UN271, tracked in motion, drifting against a sparse star field. But next to it, offset by only a few arcseconds, was a faint echo, a second brightening, not a reflection, not a lens flare, a twin burst. Within hours, others began reporting the same anomaly. Observatories from Argentina to South Africa confirmed it. UN271 was pulsing, twice. Not in brightness alone, but in rhythm. When the Allen telescope array revisited its frequency data, the evidence became undeniable. The base harmonic signal, the UN271 signature, had doubled in modulation. Every primary pulse now came with a secondary echo. Shorter, fainter, but always present. The time gap, exactly 89 milliseconds. Another Fibonacci number. They called it the double pulse. In radio astronomy, pulses aren't uncommon. Rotating neutron stars, pulsars, emit regular electromagnetic beacons. But their pulses are consistent, mechanical, unchanging. What made UN271's double pulse different was the relationship between the two signals. The second pulse wasn't a copy. It was an inversion. Spectral phase analysis showed that the second echo consistently reversed the waveform of the first. Where the primary pulse crested, the secondary dipped. Where it surged, the echo fell silent. This was not just a twin, it was a counterpoint. Some likened it to binary signalling, like a 1 and a 0 in an interstellar computer. Others thought it resembled a biological heartbeat, systole and diastole, a push and a pull. Whatever it was, it had never been seen in any natural body. And then the light pulses arrived. JWST, still locked on UN271 through its near-infrared camera, detected paired surges of energy, spaced 89 milliseconds apart, across three spectrums: infrared, near visible, and extreme ultraviolet. These surges were faint, but their consistency left no doubt. UN271 wasn't just emitting pulses, it was pulsing in synchrony, across multiple frequencies and instruments. Radio, infrared, optical, all echoing the same rhythm, double, inverted, Fibonacci timed. But the strangest part wasn't the signal itself, it was what came between the pulses. In the milliseconds between the primary and secondary burst, a pattern emerged. Not in energy, but in absorption. A microscopic dip in background cosmic noise, as if the object wasn't just sending something out, it was pulling something in. Scientists at ESA's Solar Observatory proposed a radical theory. The double pulse wasn't just a signal, it was a mechanism, an interaction cycle between UN271 and the vacuum around it. A push into space, followed by a draw back in, like echolocation at a cosmic scale, or a breath. A few dared to whisper another term, a dialogue. If the primary pulse was a question, and the echo was an answer, then UN271 wasn't just transmitting, it was responding. To solar wind, to gravitational vectors, perhaps even to observation itself. And if that were true, then we hadn't just found a signal, we had entered the conversation. Comets rotate, asteroids rotate, even interstellar objects sculpted by ancient collisions and gravity fields carry angular momentum. Rotation is the cosmic fingerprint of formation, of time, of force. But UN271 broke that rule. When astronomers observed the object on the morning of November 23rd, 2025, they anticipated spin. It had passed near the Sun and had been exposed to solar heating, conditions that normally induce torque in asymmetrical bodies. But over multiple high-resolution observations from both orbital and terrestrial instruments, one detail stood out. There was no rotation. Not slow, not subtle, not hidden behind shadow or debris. None. Photometric readings from the Cerro Tololo Inter-American Observatory in Chile showed a flat-like curve over 12 continuous hours. The James Webb Space Telescope confirmed this in the infrared, showing no fluctuation in surface temperature distribution. ESA's Solar Sentinel radar, satellites returned identical results. No Doppler drift, no axial wobble, no tumbling motion. UN271 was not spinning. That is not natural. Objects in microgravity don't stop rotating without intervention. The lack of detectable spin suggested two scenarios. Either the object had a flawlessly balanced mass, or it was under some form of active stabilization. Neither should be possible. A naturally symmetrical object of this scale would require perfect formation, no impact scars, no structural deformation, no outgassing events. But UN271's outer surface was jagged, marked by striations and irregularity. It looked ancient. It looked damaged. It did not look balanced. So the alternative gained traction. It was being controlled. Some proposed internal gyroscopes, reactive mass drivers, or spinning cores. Others speculated about magnetic coupling with the solar field, some unseen mechanism holding the object in a fixed attitude. But silence followed. No agency offered a public explanation. The data was clear, but the interpretation was avoided. Rotation is not a footnote in orbital science. It is a cornerstone. It reveals internal structure, origin, mechanical history. Without it, everything becomes a mystery. Without spin, there is no past. And yet here was UN271, gliding through space with undeniable precision, without the fingerprint of spin. Not even Oumuamua, the first known interstellar visitor, showed this kind of control. It tumbled. UN271 did not. The stillness was not an accident. It was intention, or worse, necessity. What if the systems inside, or on, the object could only function in perfect orientation? What if rotation would disrupt whatever it's doing? Some proposed directional communication, tightly aligned scanning systems, or propulsion elements that required absolute stabilization. Because if an object does not spin, but it still navigates, then it is not being moved by chance. It is being steered. And motion without rotation is not just strange, it is engineered. It didn't come from NASA, or ESA, or any university-backed research team. It came from a kitchen table. A Reddit user going by the name SolarLens89 posted a short video clip on the morning of November 23rd, 2025. The video showed a series of telescope frames stacked into a simple animation, 24 seconds of motion across the night sky. It was grainy, overexposed in some frames and visibly unfiltered, but it caught something the world's best observatories had missed. UN271 wasn't alone. Alongside its faint silhouette, just to the left and slightly above the object's light core, another body flickered in and out of visibility. It didn't appear in every frame, and it didn't follow the exact same path, but it remained in proximity, close enough to rule out a star or pixel artifact, far enough to suggest independent movement. At first, the video was dismissed. Amateur videos are notoriously unreliable, full of lens reflections, pixel ghosts, atmospheric distortion. But then another video appeared, and then another. By mid-afternoon, 23 independent uploads across 6 countries had surfaced, each showing the same anomaly. A second body near UN271, moving in parallel but not in sync. Amateur astronomers began coordinating in real time, sharing coordinates, adjusting exposures, switching filters. Some set up multispectral imaging arrays in their own backyards. Others used remote telescopes rented from observatories in Australia or South Africa. Within hours, they had established what institutional scientists had not. There was something following UN271, and it was pulsing, not flashing, not flickering, pulsing. At intervals that matched the Fibonacci-timed double signal first recorded by professional radio telescopes. The amateur community gave it a name, echo body. Some speculated it was a fragment. Others thought it might be a debris field reflecting the same signals, but a few made a deeper claim. This second body wasn't random. It was synchronized, not just in motion, in light. Its pulses mirrored UN271's, but not identically. Every time UN271 emitted its double pulse, the echo body responded with a delayed inversion, almost like a conversation, a call and response. This made the amateur data even more valuable. Unlike large observatories that follow rigid protocols and locked-in targets, the amateur network had creative freedom. They experimented with exposure times, frame stacking techniques, and alternative filters no institution would normally use. And in doing so, they revealed a level of complexity that most official datasets had missed. By evening, several astrophysics forums and Discord servers were overflowing with triangulated trajectories, pulse timing spreadsheets, and 3D simulations showing the relative motion between UN271 and the echo body. Some engineers even began constructing signal models to replicate the phase delay structure between the two objects. Then the silence began. Top posts sharing the original footage were suddenly deleted. Entire threads vanished from major astronomy communities. A few users posted cryptic follow-ups, saying they had been contacted by someone and told to remove their uploads. Others disappeared without explanation. But not everyone could be erased. Not every hard drive could be wiped. And one question refused to vanish. Why did amateur observers detect the echo body first? And why did it respond in Fibonacci rhythm? The answers weren't coming from space agencies. They were coming from basements and bedrooms, field tents and forest clearings, where people pointed second-hand optics at the sky and caught a glimpse of something silent, something that didn't want to be seen. But once seen, it could not be ignored. It happened without press, without notice, without a name. On the evening of November 23, 2025, users tracking the European Space Agency's internal catalogue noticed something strange, a metadata change. UN271, which had been labelled as a comet for nearly 2 years, had been quietly reclassified. The new tag read, Unclassified Interstellar Mass. There was no bulletin, no press release, no alert to institutional astronomers. And yet the label change was real, confirmed through the backdoor catalogue mirrors maintained by several independent research networks. Within hours, screenshots began appearing on physics forums, and obscure Discord servers focused on observational anomalies. This wasn't just a matter of semantics, it was a removal. By stripping the comet designation, ESA effectively detached UN271 from the known behavioural models, no longer tied to outgassing, coma formation, or solar tail dynamics. It was no longer part of the solar system's extended family. It was officially foreign, and the timing couldn't be ignored. The reclassification came less than 12 hours after amateur astronomers uploaded footage of the echo body, and just 2 days after the first detection of the double Fibonacci pulse. So what triggered the shift? Insiders believe it wasn't a single data point, but a convergence of anomalies, the absence of thermal emission, the complete lack of rotation, the inverted pulse structure, and now the presence of a second object moving in parallel, yet distinct in behaviour. This didn't look like a natural object. It looked like a system, and systems aren't random, they are designed. By marking UN271 as unclassified, ESA did more than avoid responsibility. They created distance, scientific and legal. It allowed the agency to continue tracking without falling under planetary defence protocols or near-Earth object hazard procedures, because comets are monitored, but unclassified interstellar masses, they are merely watched. This subtle linguistic change had consequences. It triggered an internal handover. Tracking authority was transferred from ESA's Public Astronomy Division to a private contractor in Darmstadt. From that point forward, real-time imaging was suspended. No more open access, no spectral profiles, no error margins, only summarized trajectory vectors, uploaded twice a day, bereft of timestamps or associated raw data. To the outside world, UN271 still existed, but its context had been erased. Why reclassify it in secret? One theory is internal disagreement. Some scientists may have pushed for continued public access, others for containment. Another is panic control. Comets are familiar. Unclassified objects are not. But the most likely explanation is procedural containment. As long as UN271 remained just a comet, it was visible to everyone. By altering its classification, ESA could dictate what data was shared and what story was told. Or more precisely, what story wasn't told, because classification is narrative. It gives shape to speculation. When you take away the name, you remove the permission to ask questions. What's left is just a shape in the dark, unlabelled, unexplained, untouchable. And if that shape begins to move, the silence isn't passive, it's strategic. Gravity doesn't echo. It bends, it pulls, it distorts, but it doesn't repeat. Not in the way we understand waves. And yet, on the morning of November 23rd, 2025, something changed. 3 gravitational wave observatories, LIGO in the United States, Virgo in Italy, and Kagra in Japan, all recorded a signal that didn't fit any known profile. It was low frequency, near the detection floor, almost symmetrical, and it repeated. Once every 42 minutes, the same curve, barely above the noise, but unmistakably there. The signal lasted 14 hours. At first it was dismissed, written off as terrestrial interference, perhaps micro-vibrations in the tectonic crust, instrumental drift, or syncing errors between facilities. But cross-analysis ruled all of it out. Because the waveform matched across continents, it passed through Earth, which meant one thing: the source was in space. But what kind of object emits rhythmic gravitational pulses? Black hole mergers? No, the frequency was too low. Neutron star collisions? Too weak. The shape was all wrong. It wasn't an explosion, it was a rhythm, like a bell being struck, lightly, precisely, with timing. And it matched something else. The signal appeared to resonate within a specific orbital band, not above Earth, but in the corridor between Earth and the Sun. More precisely, the frequency aligned with a gravitational resonance between UN271's path and Earth's Lagrange point 1. That narrowed it. The source was either near UN271 or part of it. Some theorists proposed the object was engaging with gravity, not passively following orbital mechanics, but rhythmically interacting with gravitational fields, as if the object was shifting mass internally, steering, balancing, stabilizing. But gravity is not something we emit, unless it's being modulated. The idea sparked a new line of thinking. Could this be a byproduct of propulsion? Some kind of drive system that manipulates local gravity fields not through thrust, but through resonant pulses, not violating physics, but riding its edges. And then it got stranger. SETI researchers joined the conversation, because when they ran the gravitational signal through harmonic analysis, they discovered a recurring ratio, the same Fibonacci timing found in the photonic double pulses coming from UN271 and the so-called echo body. Light and gravity, both behaving rhythmically, both echoing the same numerical code. Patterns like this don't emerge by chance. They are built, shaped by intention. And when two separate physical layers of the universe, electromagnetic and gravitational, begin pulsing in harmony, the question changes. It's no longer, what is it doing? It becomes, who is it talking to? Because signals don't just reveal presence, they imply audience. Shape defines expectation. In astronomy, form tells a story of impact, erosion, radiation. A comet's uneven surface speaks of fragmentation. An asteroid's rough edges echo a violent past. The solar system is full of chaos, and shape records it. But UN271 breaks the rule. Captured in high-contrast frames by both amateur deep-sky observers and ESA's early-phase tracking arrays, its silhouette did something strange. It didn't rotate chaotically, it didn't tumble, and most importantly, it didn't look natural. The body was smooth, not smoothed by time, not rounded by collisions, but geometrically constrained. Measurements from different vantage points stitched together over several passes revealed something deeply unsettling. A repeating curve ratio that mirrored a partial torus. The edges were consistent. The light scattering across its surface followed no randomized contour, just an even gradient, with no angular disruption. The perimeter showed no craters, no divots, no debris trails, no randomness, and its size, spanning over 150 kilometers, only magnified the oddity. Because no known geological process can create uniform curvature at that scale. Not without folding, fractures or fractures. Next came thermal modelling. Passive infrared telescopes showed something even more bizarre. The surface radiation was even. No hot spots, no cold shadows, just a consistent, regulated bleed-off of energy. The temperature profile resembled engineered insulation. Speculation erupted. Was it a ring? A disk? A Dyson fragment? Some argued that it might be a shell, hiding a central body we couldn't yet resolve. Others speculated it was modular, an array of repeating units giving the illusion of a single structure. Some theorists even revived the concept of structural cloaking, objects built to appear as geological masses while hiding architecture inside. But space doesn't respect illusions. Gravity doesn't lie. As UN271 drifted closer to its perihelion corridor, the nearby probe debris fields and microsatellites began to bend. Not toward the Sun, not toward a mass centre, but along arced trajectories that didn't match any known orbital expectation. This wasn't standard gravitational pull, it was shaped influence, as though the object had internal mass control, balance, not by chance, but by design. And then came the radar maps. 2 passive arrays, one ground-based in New Zealand, the other relayed through a commercial Lunacom satellite, sent narrow-angle radar pulses during a rare signal window. The returns were faint, but they were not random. The structure map revealed something few expected: straight lines, repeating intersections, and a single, recessed ridge, running along one edge of the visible curve, consistent with structural seams seen in high-orbit megastructures, like solar panels or shielding interfaces. It defied every model for comets, asteroids, or interstellar rocks, because it wasn't a rock, it was a form, built not by erosion, but by instruction. And while astronomers tried to resist the implications, the evidence became harder to ignore. UN271 wasn't shaped by space, it was shaped for it. The Doppler effect is one of astronomy's most reliable instruments. By observing the shift in wavelength from an object, scientists can measure its motion, whether it's moving toward or away from Earth, and at what velocity. It's how we track exoplanets, how we measure expansion, how we watch the universe breathe. But with UN271, the tool broke its own rules. When ESA and NASA pointed their radio arrays at the object, hoping to establish baseline motion through standard redshift-blueshift analysis, they expected clarity. They received contradiction. In the same signal window, some wavelengths shifted red, while others shifted blue. Different parts of the same object appeared to move in opposite directions. At first, the anomaly was dismissed. Radio interference crossed telemetry, atmospheric contamination. But the interference repeated, and it followed a pattern. Every 88 seconds the signal flipped, red to blue, blue to red, consistently. This wasn't drift, it was rhythm, and it made no sense. In classical Doppler analysis, conflicting velocity bands would imply a spinning object with fast axial rotation or a highly fragmented structure. But thermal and visual imaging ruled that out. There was no chaotic rotation, no dust halo, no spiral debris to account for the phase inversion. That left only one explanation. The object was modulating itself, not just moving, signalling. Imagine a lighthouse. But instead of flashing light, it flashes motion. By manipulating the direction and timing of its energy reflection, an object can appear to speed up, slow down, or reverse. Not randomly, but with precision. Further simulations suggested a mechanism, a rotating surface geometry, perhaps panel-based or disk-structured, tilted in and out of the detection vector. That tilt could deliberately mimic Doppler velocity shifts. In other words, UN271 wasn't just reflecting signals, it was shaping them. The signature wasn't a bug in the system, it was a feature, and it gets stranger. Physicists quickly noticed that the 88-second timing wasn't arbitrary. That interval mirrors a known harmonic resonance found in binary pulsar echo windows, the precession of Earth's axial wobble, timing gaps in solar neutrino streams. 3 unrelated systems. 1 shared number. Why? Because in physics, some numbers are easier to notice. They stand out across disciplines, across civilizations, across instruments. The implication? The Doppler interference wasn't just a byproduct of movement. It was engineered legibility, a waveform signature designed to trigger investigation by any species familiar with motion detection. Like carving letters into the wind. And the message wasn't complex. It didn't say where it came from. It didn't say why it was here. It just said one thing. I'm not noise. In orbital mechanics, motion is governed by 2 forces, gravity and momentum. Objects fall, swing, and curve, not by will, but by the pull of mass and the push of speed. Trajectories are natural outcomes, but when an object's path begins to lock, to repeat, to align, to anticipate, something has changed. That's what astronomers noticed with UN271. Its trajectory wasn't just a predictable curve through space, it was a synchronized pattern. When researchers overlaid the object's path with the sun's heliomagnetic field, something strange emerged. The solar field, which rotates on a roughly 27-day cycle, causes its magnetic lines to twist like threads in space, and every time this rotation reached a reversal threshold, UN271 adjusted, not randomly, not gradually, but in sync. This shouldn't be possible. Rocks don't respond to magnetic field rotation. They drift, they fall, they spiral, but they don't phase lock unless something is telling them to. Further analysis made the picture even stranger. UN271 didn't just follow the heliomagnetic pattern, it anticipated it. On at least 3 separate occasions, the object changed vector minutes before the magnetic field realigned. It moved in advance, as if it had been warned. The only mechanism that could explain this behaviour was a reactive guidance system, an onboard system capable of reading, modelling, and responding to solar field dynamics in real time. And this shifted the interpretation. UN271 was no longer on a passive trajectory. It was engaging in dialogue with the Sun. The strongest evidence came from the timing. Each phase alignment occurred exactly 6 minutes after the Sun's magnetic reversal completed, not 5, not 7. That's calibration. It meant the object wasn't drifting, it was tuning, like a satellite locking onto a carrier signal, like a drone syncing with a beacon. To match solar field behaviour this precisely, it would require not just awareness, but computation, analysing gradients, measuring resonance, predicting future curvature. It would require listening. UN271 was not walking a gravitational slope, it was balancing on a magnetic tightrope, and it did so with more stability than any Earth-launched probe. To be clear, phase locking is not a fantasy. It's been proposed for next-generation sailcraft, vehicles using solar pressure and field resonance for ultra-efficient motion. But executing this method demands continuous calibration, microscopic adjustments, and field awareness on the scale of subparticles. We're not there yet, but UN271 is. Which leads to a deeper question. If the object is adjusting its trajectory to match the Sun's field, not randomly, not occasionally, but on schedule, then what's giving the instructions? What is observing the field? What is calculating the shift? And what is choosing the moment to move? Because magnetic fields don't shout, they whisper in quiet curves, in twisted tension, in soft fluctuations, and the only thing that can follow those whispers is something meant to hear them. Some paths are followed, others are chosen. UN271's motion through the solar system began as a mystery of origin, its composition, rotation, and surface. But as trajectory data matured, the focus shifted from what it was to where it was going. Because this object wasn't just moving, it was aligning. On November 23rd, orbital analysts noted an angular convergence in its trajectory, not with a planet, not with an asteroid belt, but with a satellite corridor. Specifically, UN271's path cut directly through the orbital window used by NASA's Stereo-A probe, a solar observation satellite launched to monitor coronal mass ejections. The overlap wasn't approximate, it was clean, precise, timed to the second. At first, it was dismissed as coincidence, but orbital mechanics rarely produce that kind of alignment unless by design. The phenomenon is known as interception geometry, an intentional flight path that converges with another object's space and time window. It's typically reserved for rendezvous operations, like docking, data relays, or interception. But this wasn't a spacecraft returning home, and it wasn't Earth that programmed the manoeuvre. The anomaly deepened. Further trajectory modelling revealed multiple past alignments with high-altitude comms relays above the Pacific. Future projections showed upcoming near passes through the heliocentric transmission zone of the SOHO and Parker Solar Probe. In each case, the object's path wasn't just crossing orbital space, it was threading through communication arteries. And then came the speed data. Each time UN271 approached one of these narrow corridors, its velocity subtly adjusted, decelerating just enough to enter the intersection window, then resuming baseline speed afterward. The adjustments were slight, just a few meters per second, but enough to change the timing of the pass by minutes. That level of modulation isn't passive. It requires precision sensing, pre-mapped spatial data, and goal-oriented navigation. In simpler terms, it requires intention, because while comets drift and slingshot, this object was targeting. Its route resembled a scouting loop, not one meant to observe planets, but one optimized to interact with machines. The pattern matched the logic of survey probes. vehicles designed not to visit or land, but to pass through existing information systems, to read our lenses, to map our watches, to study the way we study. And if that sounds strange, consider the perspective. If you were tracking a civilization from far away, would you need to contact every planet? Or would you just intercept its data paths? UN271 didn't just approach Earth, it glided through the invisible scaffolding we use to observe the sun, like it was checking the mirrors behind the curtain. This was not a comet on a scenic tour, it was something else taking inventory. Each geometric convergence, each slowed approach, each precise corridor pass pointed to the same conclusion. UN271's path wasn't gravitationally efficient, it was informationally efficient. It wasn't mapping the planets, it was mapping us. And not the part we show in telescopes, but the network behind the lens, the machines that listen, the satellites that whisper, the quiet threads of the species watching the sky. A comet, by definition, is a body that reacts. Approach a star, and ice sublimates, dust erupts, a coma forms, a tail arcs, activity is identity. But UN271 doesn't react. No outgassing, no coma, no visible ejection. And that silence has created a scientific deadlock now known as the null comet problem. The problem is simple. UN271 was classified as a comet due to early orbital simulations, which suggested a high eccentricity solar approach, consistent with known Oort cloud visitors. The size was large, over 100 kilometres, and early estimates assumed it was dormant until it reached the inner system. But by November 23rd, when the object had already crossed the threshold of thermal activation, for every known volatile compound, it remained inert. No flare-ups, no jetting, no thermal blooming. Even water ice, usually the first to sublimate, remained silent. This forced a re-evaluation. Because if a comet shows no signs of being a comet, can we still call it one? The physics say no. A body that doesn't outgaze under solar pressure is not behaving as a comet. And the longer UN271 remained still, the harder it became to justify the label. So researchers looked deeper. They pointed every available infrared and spectrographic tool at the object, searching for trace gases, carbon monoxide, methane, formaldehyde, ammonia. Nothing. No volatile spectrum, no absorptive dips in the expected bands, no signs of crust cracking, surface expansion, or internal venting. It was a perfect blackbody, radiating heat passively. So if not a comet, what was it? Some argued for asteroid reclassification, but even that didn't fit. The object's density, derived from gravitational interactions with nearby dust and probe flybys, was too low to be a rock, but too high to be fluff. It sat in a classification dead zone, neither comet nor asteroid. Then came the null reflection data. High-angle solar backscatter showed something that broke the model completely. No particulate veil. Every known comet, even dormant ones, emit tiny reflective particles that create a dusty halo around their bodies. These particles scatter light and change polarization under certain angles. UN271 had none. The space around it was clear. This was not just a silent comet. It was an empty one. The conclusion grew harder to avoid. This object was not natural in behaviour. It refused to behave, and that refusal created a paradox. Either UN271 was a comet with impossible physical traits, or it was never a comet to begin with. But then, why the orbital mimicry? Why approach the sun in the same eccentric arc as traditional comets? Why follow a path that looked familiar but never played by the same rules? This is where the null comet problem becomes more than semantics. Because if the object's identity is intentionally misleading, if its silence is deliberate, then it may not be a natural artifact at all. It may be designed to pass as one, just close enough to what we expect to avoid suspicion, until it's too late to reclassify. UN271 challenges more than naming conventions. It challenges detection logic. Because if we only label based on motion, and if the motion can be mimicked, then we are blind to what hides in the mimicry. Mass doesn't lie. In orbital science, velocity can trick the eye. Brightness can be misleading. Even trajectory can be manufactured with clever geometry, but gravity never pretends. The way nearby objects respond to a passing body tells you exactly how much mass is inside. No assumptions, no illusions. And in the case of UN271, that response changed everything. On November 18th, the object passed near a loose cluster of solar probe debris, metallic fragments left from older flyby missions between Earth and Mars. These fragments, while inert and floating, are still sensitive to gravitational influence, and they moved. Not by much, only a few millimetres per second, but enough to register on ultra-fine instruments watching from ESA's mid-range orbital sensor grid. At first, analysts assumed standard perturbation. Comet passes by, small gravitational tug occurs, but when they reverse calculated the mass needed to cause that level of shift at that exact distance, they were stunned. The object was far too light. Its visible size, estimated at over 100 kilometres in diameter, implied a mass many orders higher than what was detected. In fact, based on gravitational pull alone, UN271 had less than half the expected mass. The term for this anomaly is simple but devastating: mass discrepancy. There were only two possible explanations. Either the object was constructed from ultralight materials unknown to natural formation, or it was mostly hollow. Neither answer was comfortable. The lightweight theory meant the body was made of something exotic, not rock, not ice, but structured composites, something engineered, something forged. But the hollow model introduced something worse: interior architecture. If a large portion of the object's interior was empty space, with only an outer shell to support the observed shape and reflection, then the object wasn't just a mystery, it was a design. Further clues came from radar data. ESA and CNSA ran simultaneous sweeps using long-pulse radar from Earth orbit and lunar relay arrays. The results showed that echoes from the far side returned too quickly, as though there was less material for the signal to pass through than its visual diameter suggested. And in one of those returns the echo wasn't smooth. It splintered, as if bouncing between internal surfaces. If UN271 is indeed a shell, then every assumption about its purpose must shift. Shells imply containment, they imply function, and they imply intent, because nature doesn't build empty megastructures. People, or something like people, do. The idea of a shell also explains other anomalies: the lack of outgassing, the perfect thermal radiation profile, the phase-lock trajectory, the absence of rotational drift. Each puzzle piece, disconnected on its own, begins to fit when viewed through the lens of construction. UN271, then, would not be a comet. It wouldn't even be a probe. It would be a carrier, a shell enclosing what? No instruments have penetrated deep enough to see inside. No signature has leaked from its centre, but its mass speaks louder than any reflection. And what it says is simple: this is not a rock, this is not debris, this is not random. It is a vessel, and vessels don't drift aimlessly. They arrive. Magnetic fields in space are rarely stable. Around most celestial objects, comets, asteroids, even planets, the magnetic environment is shaped by chaos. Pulses, surges, solar wind interference, cosmic noise, but not here. Around UN271, researchers noticed something else. Starting on the morning of November 23rd, field telescopes at the Mauna Kea Observatory in Hawaii detected soft, periodic fluctuations in the local magnetic environment. These weren't typical field interactions. They were pulses, measured, predictable, and remarkably consistent. Every 132 seconds, the object emitted a low-intensity expansion in its surrounding magnetic field, then contracted again. Not once, not twice, but dozens of times over a 12-hour window. This regularity gave rise to a new term: the breathing field. The phenomenon wasn't subtle. Field strength expanded by roughly 0.02 microteslas, then returned to baseline, over and over, like a heartbeat in the vacuum. Scientists immediately looked for natural causes. Could it be a reaction to solar wind pressure fluctuations? No correlation. Could it be ambient magnetic compression from solar sector boundary crossings? Again, no match. The field rhythm wasn't reactive, it was endogenous. That changed everything. Because magnetic breathing, as a behaviour, requires internal energy. It implies a controlled mechanism, generating a cycle from within. Nothing in the known natural catalogue matches this. Even Earth's magnetic field, generated by a rotating molten core, doesn't pulse this evenly. No comet has ever demonstrated rhythmic magnetism. Even asteroids with trace metallic content show random fluctuations, not deliberate timing. This field wasn't being pushed, it was being broadcast. The implications were immediate. An object with rhythmic magnetic output is either testing its environment, communicating through modulation, or maintaining internal stability via field cycling. Each option implies awareness. Because, to breathe rhythmically, an object must first perceive resistance. It must know when to push and when to pause. In short, it must sense. One hypothesis suggested that UN271 might be actively probing its surroundings, using these magnetic pulses to read solar plasma density, particle dispersion, or magnetospheric echo profiles. In this model, it was sending out feelers, not unlike sonar, but using magnetic gradients instead of sound. Another theory proposed resonance tuning, a method of staying in phase with the Sun's larger magnetic oscillations, possibly to reduce drag or stay locked to a solar reference frame. A third idea, more unsettling, speculated that the pulses were designed not for space, but for observation. That UN271 might be triggering specific magnetic signatures to test for sensor response, like knocking on a wall to see if anyone listens back, and the object's perfect silence, visually and thermally, added weight to that final theory. Because silence isn't always an accident. Sometimes it's an experiment. The breathing field may be the only expression UN271 has allowed us to observe, while the rest remains hidden, deeper inside. Whatever the purpose, the data is clear. This isn't ambient. It isn't chaotic. It isn't solar. This rhythm is its own, and whatever is generating it knows it's being watched. The twin hypothesis didn't begin with a sighting. It began with a shadow. As UN271 drifted across the field of view from different hemispheres, a group of amateur astronomers in Chile and South Africa captured overlapping long exposure images. They were attempting to map the faint light distortions near the object's trajectory, but when the frames were overlaid, something unexpected emerged. A second object, dim, offset, quiet, but moving. At first it was dismissed, a background star caught in a fluke alignment, maybe sensor noise, maybe a lens artifact, but it didn't stay still. The anomaly moved between frames, slowly, yes, subtly, but in perfect harmony with UN271's known motion. Frame by frame, the object traced a path not random but locked. The measured distance between them, roughly 2,000 kilometers, far enough to rule out physical tethering, close enough to raise every red flag in orbital mechanics, because that spacing remained constant, not drifting, not wobbling, not degrading. It was following. And following at that range, without visible propulsion or gravitational slippage, requires more than coincidence. It requires coordination. What made it more compelling wasn't just the movement. It was the absence of everything else. The twin had no infrared signature, no magnetic emissions, no optical flare beyond the bare minimum to confirm it existed. It didn't announce itself, it just mirrored. The deeper telescopes looked, the more strange it became. Spectrographic sweeps from the European Southern Observatory showed no spectral fingerprint at all. Nothing reflected, nothing absorbed. It was as if the object intentionally refused interaction with light. Radar ping attempts failed, no bounce, no return. But gravitational micro-tugging on the fringe particles near UN271 confirmed it had mass, just enough to make a difference, just enough to be real. And then came the moment that shifted everything. On the morning of November 23rd, as UN271 performed a subtle lateral correction, an arc adjustment of just 0.4 degrees to its heading, the silent object followed suit, not seconds later, not minutes later, but in unison. Both objects adjusted course with identical timing and proportional vector shift. That event ruled out randomness completely. This was not a companion fragment, not a trailing piece of ejecta, not a floating coincidence. This was a partner, and it introduced an entirely new question. If UN271 is a shell, what is its twin? One theory suggests the silent twin is a sensor relay, a data forwarding node designed to keep a clean signal arc between the main object and some far-off receiver. Another proposes it is a decoy, a silent mass designed to confuse planetary defense systems or delay detection through interference. But one hypothesis rose to the top after field researchers cross-modelled the object's relative placement. It's a shadow module, a synchronized structure designed to mimic gravitational interaction without revealing internal behaviour. In this model, the twin may act like a mask, disrupting how UN271's mass reads on Earth systems by creating false positives in momentary occlusions, frame jitter, and field diffraction. A kind of cloak, but one built with physics, not projection. Whatever its true role, one thing is now clear. UN271 does not travel alone. It is accompanied, followed, synchronized, and its twin is not loud, not fast, not dangerous, at least not in a way we can measure. It is silent, but in space, silence can be more alarming than signal, because silence isn't absence. Sometimes it's intention. Some questions don't have answers, others were never meant to be asked. As the final datasets from UN271 trickled in on the morning of November 23rd, a growing pattern began to unsettle even the most grounded astronomers. The puzzle pieces were strange on their own. Thermal silence, mass discrepancy, magnetic pulsing, the synchronized twin. But taken together they formed something worse than uncertainty. They formed a design. Because every data point, every field emission, every reflection spike from the main body behaved in one very specific way. They gave us just enough to detect, never enough to explain. We weren't seeing the full picture. We were seeing exactly what it wanted us to see. And that's not what natural bodies do. That's what intelligence does. Not just any intelligence. One that understands us, understands our methods of detection, our limits of analysis, our tendency to theorize, and then it cut the line. Shortly after the twin adjusted, course, less than 90 minutes after the final positional sync, data streams from 3 orbital solar instruments lost coherence. They didn't crash, they didn't glitch, they just went quiet. Transmission protocols remained open, but the packets were empty, time-stamped, routed, formatted, but blank. At the same time, a low-band ripple began to appear across deep space comm arrays, a frequency band unused since the Voyager missions in the 1970s. The ripple wasn't structured data. It wasn't audio. It wasn't even noise. It was a placeholder, as if someone or something had reached back through the silence and inserted a signal that said, "You've seen enough." That was the turning point, because up until then the question was always, what is UN271? A comet? A vessel? A false positive? But that morning the question changed. It became, why is it performing like this? Why fly a trajectory that mimics natural comets, but omit every defining behaviour? Why synchronize movements with a silent twin, while avoiding any interaction with earthbound systems? Why broadcast magnetic pulses in measured rhythms, only to stop just as analysis begins? Why allow detection, but never revelation? And most of all, why ensure that we notice? Because the way UN271 moves, hides, pulses, and reacts to observation suggests that its behaviour isn't passive. It's curated, carefully, repeatedly, with precision. The growing theory whispered between labs and late-night review rooms isn't about cometary formation anymore. It's about response strategy. UN271 may not be a traveller. It may be a test, a construct designed to observe how we observe, to probe our thresholds for reclassification, to push against the seams of what we call natural. And when it reached the point of greatest interest, when every instrument locked onto it, when the story began to form, it pulled away, not with speed, not with violence, but with absence. The same way you close a door, gently, once someone has seen what's behind it. So now the final question isn't about identity, it's about permission, and whether the silence now is part of a message we were never meant to finish reading. Because in the end, maybe the answer isn't missing. Maybe the answer is being withheld.